Welcome to a new test and teardown video. This time we're going to look at a radiometer. This is an AC RMS voltmeter, so it's only going to show you AC volts. They call it audio frequency, but it goes actually all the way from 20 Hertz to 2 megahertz. Input impedance is 2 mega ohm, so that is a little bit weird. I think in my world it's either 1 or 10, but in the good old days it could have been 2. And it is an all transistor unit, by the way. It can do both. It can run on both mains or on a battery, since it's an all transistor. I already shown the RV36, and that is an all tube version of exactly the same instrument. This one looks a little bit different in size and weight and all that kind of stuff, because it's all transistor. It's a lot more modern. They exist in 3 different versions, A, B, and C. This is the C version, and this is also in the very high serial number range. So this is the last schematic you will find that covers exactly this model. And you can find manuals and schematics on peel.dk. As you see here on the front, we got a little bad dent here. I will try and figure that out. And also on the back, there's another nasty one. One of my buddies picked this up a trash can, so it was thrown out. You can use this as an amplifier as well as you can just read out on the meter, but you can also take out the DC or the AC portion of whatever it is you put in. And here's of course the battery. Look at that funny battery voltage range. So it's definitely running on some quite high voltages. It even says here RV36 C, and due to the serial number, this one is the revision 3. That is from 1646-75, and since this is 19, it is definitely a revision 3. So yeah, I better open it and inspect if there's any loose components and how it's looking inside before I power it up. And you can also see there's a little bit of loose here. I think all I have to do is take away the top screws, and then I can lift up the cabinet. We got the classic radiometer locking here, so they should just lock on the side. You can feel it like that. So this is at least what I think. I hope I will be able to lift it up due to this nasty dent here. It is really nice and shiny inside. We got 2 circuit boards. This is the power supply board. It is a very funny power supply, by the way. I think we should also look a little bit on the schematic. It is delivering plus 24, minus 18. And I don't know if you can see this on the schematic here. Don't you find this a little bit funny? So the positive supply is a parallel regulator, and the negative supply is a series regulator. The positive is adjusted using the negative one, and the relationship between them, that is defined by the resistor values in this negative pickup control to the positive side, right? So I think it's a little bit funny to see this parallel series regulator system. You don't see that a lot. And there's a little adjust. And the idea is you measure the negative 18, and then you do the adjustment, and then you hope for the plus 24 to align correctly. At least that is what I want to do first. Inside here we got the main circuit board. It is divided into two different sections. The front part is, of course, the first amplifier. And just before this first amplifier part of the board, we have the input attenuator, and that is located in a little shielded metal room here all by itself. I don't know, we can't really see a lot in there. It's just some resistors and capacitors and switches and stuff like that. Also, we got a little variable capacitor here to match the frequency compensations using match of the capacitance over the resistor dividers and all that kind of stuff. The funny thing about this schematic, if we look at the schematic here, is it's just NPN and PNP transistors, no field effect transistors, no op amps, no fancy smancy special parts, just super easy, simple to get parts. So I should definitely be able to repair this and measure around and figure stuff out if I am not super lucky and it just works. The power supply mains transformer is super tiny. Of course, this is only 4 watts, or was it 4 or 5 watts? The funny thing is, you see 3 wires on the primary side, right? One of them go to a fuse. The fuse is, of course, located here at the back. But the other one is the first 110 volt tapping. So the 3 wires from the transformer input side goes to the on-off switch. And here is the funny thing. The power on indicator is a neon bulb. And the neon bulb is, of course, connected to the 110 volt tapping. And then you see the black and the gray wire. That is the mains entry. And then this wire goes down here to the neon bulb. So this placeholder here, they don't really use this. They just use this to hold the wires. That's a little bit funny. At the beginning, it was quite confusing. I just looked at it like that, and oh no, what is that funny switch and stuff? And I am a little bit lucky to see we got a proper chassis protective earth wire in the mains cable, so it is possible to mount a proper connector and not this absolutely wrong one here that is not working in my country. Because I really need protective earth when I'm playing around with old silly stuff like this. I don't want to blow up any of my other instruments. And that is what protective earth will save me from doing. I feel I am ready to power it up. So let's do that. No. 2.8 watt. And it's going a little bit unstable. I don't know what is it measuring. I don't know if you can see this, but it's going a little bit random. So this is a classic 1971 type of connector. This is called a PL259. And I got, of course, an adapter here. So I should be able to go back to BNC. And my input is 0.8 volt RMS in 1 kilohertz. Let's see what happens. And enable. Are you kidding me? So you still have a little bit of unstable behavior. It's probably related to the power supply or something, or just, I think I'll leave it a little bit and play with the different ranges. But that is 0.8. I'm super happy about that. Let's go to 3 volt range. Oh, look. Okay, this is obviously, no, it's not me who is causing the Ooh, fancy. Let's do a 2 volt RMS. It should go right there. So if this is 10, we could do 6 volt RMS and it should go to. I think it's quite accurate and all that, but there's a little bit of unstable behavior. I think I figured out what it is. Now I'm in 10 millivolt range and my input is 9 millivolts. So it's a little bit low, and that is a classic in all the different ranges. It's just a tiny, tiny little bit too low. So that should be super easy to adjust. But if you look really, really careful, you can see that the needle is moving very, very little now and then. And now I know what it is, because I'm always powering stuff using my variable AC, my Vario. And if I grab my Vario here and now I will move it like 5 volts up and down. Look now. Up, down, up, down, up, down, up, down. I think I'm doing like 10 volts peak here, right? So you can see I'm creating more or less the same behavior, right? So it is simply the way that the power supply is made. There isn't a perfect mains voltage variation rejection. That is just what you see here, and it's just a quarter of nothing. It's not a big deal, but since it is at the moment in the middle of the evening where everybody is cooking and turning on and off whatever kind of heavy machinery they got, this is why you do see these fluctuations in my mains supply. I could of course try and power this using something else, and then it should probably go away. We could try the battery input. That should be a great idea, and see if that should work. So now I'm running on DC, and I still see this unstable behavior. Maybe it's a tiny little bit smaller. I don't know if you can really see the needle is moving up and down a very little bit. This is the DC output. So I'm just monitoring if these two things are they doing the same? Is it the meter that is doing it, or is it something? I try to give it a little, and I don't really seem to be able to do any of that. Or also give a little nudge on the switch. And so I'm running on 60 volts DC input. So this is 2 volts down, 2 volts up, 2 volts down, 2 volts up. And see? It has nothing to do with the supply voltage. So that means when I was poking around with my Vario before, and I thought, ooh, this is affecting that, it was just because the timing when I was moving the voltage up and down, it's just the same kind of fluctuation speed that this is moving, as you can see here. Just a little bit up and a little bit down, sort of. And I tried to put on the cap in it, and it's the same. It can't be my signal generator that is doing this, right? I don't know. Maybe this is just normal. This is, of course, I mean, it is a quarter of a line here on the meter, so it could even be normal. It is that little, really, so it's probably only me who's seeing this. I haven't yet given up completely. So this is the bottom side of the circuit board and the main board. And now we can see the input attenuator. And since this problem is not affected by me moving around here with the switch, that means I don't believe it has something to do with that at all. but we got a little bit of dirty fingerprints here. So can it be a leakage? So we could try and clean the circuit board. We could also try and change a few of the tantalum capacitors, because they can create this kind of unstable leakage funny stuff that we see. And we got only two of them as far as I recall, right? There's an orange one right there and another orange one here in the middle of the picture, right? So, and that cost not a lot of time just to change these and see if I kind of got it just by sheer luck. Other than that, then I need to go and measure around the signal path, and it's quite a lot of gain and quite a lot of attenuation here and all that. So by measuring around in here, I'm probably going to introduce a lot more noise and hum and things. So this is not going to be so easy to figure out. I am very sure that I nailed it. Look at that. That is 9.0. And you can see how stable it is. I try not to breathe or talk or whatever you want to do. And yes, as you can see, it is a live video. But I don't know if you can see that needle, how accurate it is. And this is the 10 millivolt RMS range. And I didn't touch my signal generator at all. And now it is rock steady. And what did I do? Yes, here is what I did. I changed I think I changed more or less all the capacitors on the main board. I started with the two most suspicious, and then I walked my way through what I thought was the most suspicious kind of brands. And I just changed then 2 and then 2 and then 3 and then this one. And so I don't know exactly which one of these are to blame for the leakage, unstable behavior. But it is one or more of those capacitors that was to blame for the problem. I did find, let me turn it off and show you. I did find capacitors of exactly the same values, and I went up in voltage, never down in voltage, and this is how it looks now. I didn't change this big one down here, and I'm quite happy now. It is so super duper stable. The tantalum capacitors, I went for ceramics. I got some really good SMD ones, and I use 100 volts 10 microfarad ceramics instead of the tantalum capacitor here. One of them is 22 and the other one was 10, so that was the 10 and that was the 22, so I put two of them in parallel. I'm sorry it doesn't look so well, but these are going to keep the value for the next 1,000 years and not affect anything at all. So now I can put this back together. I am super duper happy. I also unfolded the little dent in the cabinet, and I will see if I can also unfold that one so I could pull it up. It is really nice, and I'm so happy. So now I am super duper happy and done with this unit. It is back together, and I think I almost corrected the little dents up here. Maybe it's only me who can see it, but it is quite nice and polished and working. And now we are at 0.9 volt RMS input. Just do a final speed check. So this is 1 kilohertz, and let's crank it up to 10 kilohertz. And that is 100 kilohertz. That is 1 megahertz, 2 megahertz, 3, 4, 5 megahertz. And this unit is only specified for 2 megahertz. And of course, at 2 megahertz, you see the tiny little peak. Yeah, that is 1 megahertz. And then we just go 800. Yeah, and it's rock steady. I mean, oh yeah, it was also specified for 20 hertz. Let's try 20 hertz. Yeah, okay. Then it goes shaky, shaky. 30. Okay, 30 hertz, and then it's nice and stable. 40, 50, 60, 70, 80, 90, and 100. Sometimes you can see units like this behave a little bit funny at 50 and 100. If there is interference with mains frequencies and such, then you can probably sometimes see something. But of course, this unit is now absolutely perfectly fine and working. Oops, what was that? Did you see it? That can't be good. Anyway, thank you very much for watching. I hope you had fun. Bye bye.